Assalamu alaikum. This question is from 9701, February March 2023, variant 22. Now, alkenes undergo an addition reaction with 1:1 mixture of carbon monoxide and hydrogen to form aldehyde. Figure 3.1 shows the reaction of propene with 1:1 mixture of CO and H2. And the first thing they ask, what is addition reaction? So addition reaction when two or more than two reactants add giving only one product. Now, next question, aldehyde A and B are structural isomers. State the type of structural isomerism. So at first glance, you can see uh, students think that it is positional isomerism, but it is not positional isomerism. It is, why it is not? Because aldehyde is a terminal group, so we always number it 1. 1, 2, 3, 1, 2, 3, 4. So you can see it is not aldehyde that's position is changed. It is basically structure of chain that has been changed in a B. So it is chain isomerism. Now name A as the carbon, 4 carbons. So you need to write butane, and functional group is aldehyde. So you need to write it butanol. You don't have to mention number for aldehyde group. Why? Because it is terminal group. The complete reaction of propene with with a 1:1 mixture of carbon monoxide and hydrogen produces A and B only. The product mixture contains 90%, 96% of A. So I have pasted the equation here in order to explain you question. 96% this and 4% of B. Now coming to the question, they are asking for calculate the mass of A. So mass of A you need to calculate. You are provided by 5.00 into 10 raised to power 3 kg of propene. Now for calculating this, you need to know the molar mass of propene. So what is the molar mass? For this, you need to write structural formula CH3, CH double bond CH2. And here you have, I hope you understand this. Let me make it more clear. CH double bond CH2, right? And here you have CH3, CH2, CH2, CHO. So its molar mass is 42 and its molar mass is 72 gram. And now is the time to calculate through iteration method, and you get 8571.4, and you need 96% of this mass. So to calculate 96% of this mass, 8571.4, 96% is 96 divided by 100, and your answer is 8228.5, and this is the mass of A. So you can write it 8229. Okay. Now they are asking, you need to draw a mechanism of this nucleophilic. They already told you that they are undergoing nucleophilic addition. You are provided with in a mixture of HCN and KCN. So complete this diagram for the mechanism, and you have to provide all curly arrows and everything which is required. They have mentioned partial charges. So let us complete the partial charges of carbonyl group. This is partially negative, this is partially positive. Where is the nucleophile? Nucleophile is CN minus an lone pair of electrons. Now this CN come from, as you know, KCN and HCN, two molecules. KCN is an ionic compound, so it is quickly ionizes to K and Cn. So Cn come from KCN first. Now direction of curly arrows. A very important thing you need to remember always, that curly arrows always show the movement of a pair of electron, right? So this pair of electron will make bond with this carbon, and this bond shifted as a pair of electron on oxygen. So now is the time to make a structure C O H C3H7, and charge on oxygen now become complete negative charge, and this bond shifted as a lone pair on oxygen. And here comes, just 1 minute, a bond which is formed by Cn. We need to represent it. Cn attached here. Now new molecule HCN come here. This is partially positive, this is partially negative. See what happened. These, you know, these pair of electron make bond with this hydrogen, and this bond shifted as a pair of electron on carbon, right? So here you get this molecule, and Cn minus lone pair is released as a nucleophile. So I hope you understand this part of the mechanism. Now come to the table. Table shows the information about 3 experiment involving B. So this is structure B, and they have given you some certain observation, so you need to complete the table. Now you can see a very important thing. This is an aldehyde group, and the observation is orange to green. That shows that we are using oxidizing agent, because all aldehyde are oxidized by mild oxidizing agent, and the oxidizing agent which is color orange, K2Cr2O7, is acidified, is an oxidizing agent which changes color from orange to green. Then we have another reagent that is known as Tollens reagent. You know, silver mirror test is through Tollens reagent, or you can also name it ammonical silver nitrate. Now they are asking if this structure, which is here present here, B, can what kind of change occur when you add aqueous bromine to this B? So you will simply write here no change. You know why? Because this does not contain carbon-carbon double bond. There is no double bond in it. And you know, aqueous bromine, when we talk about bromine, we always consider unsaturation of carbon-carbon, right? So it is not present here, so there will be no change. Now they are asking C4H8, O is oxidized by acidified potassium manganate. Complete the equation for this reaction using O to represent one atom of oxygen. So the condition is one atom of oxygen, okay? And your molecule is like this: CH3, CH, CH3, and this is directly attached C double bond O and H. So you know this oxygen adjusted here, converting into carboxylic acid, C double bond O, OH, CH3. So what is the number of change in molecular formula? C4H8O2, right? I hope you understand this part. And now we talk about chiral carbon. You can see this carbon is chiral. Why? Because you can see four different group around it, right? And rest we will do afterward.